Here we go. Interpreting the discriminant. We looked at the quadratic formula yesterday, which is right here, which is something we don't want to forget like I did the other day. And I've highlighted the discriminant in red. So the discriminant can actually tell us how many x-intercepts there are. So what we do is we pull it out, and you can check your formula sheet, and you can see this b squared minus 4ac is on the formula sheet. It says discriminant. So we're going to examine, like, how does this tell us how many x-intercepts we can expect? Because you don't want to use the quadratic formula unless you know there's x-intercepts, right? And we're doing this in the context of parabolas. So we talked about this before, but we could have parabolas like this or like this that don't cross the x-axis. So in the next unit, we'll see that. So there needs to be a handy way to say, hey, are there even any x-intercepts that we need to find? And that's what the discriminant helps us do. So let's kind of take a look at three scenarios here. So what can happen? If the discriminant is greater than 0, so in other words, if it's positive, it turns out that there's always going to be two real roots. So here's a quadratic. So here's the values for ABC. What are the values for ABC for this particular quadratic?
1, 6, and 5.
1, 6, and 5, right? And you just grab them. Here's A, here's B, here's C. So I'm actually using the quadratic formula here, but I've highlighted the discriminant in red. So in this case, the discriminant was 16, so we get plus or minus 4, so we end up getting two real roots. Okay? Now, here's also the graph of that particular one. So you can see, oh, there's my two x-intercepts at -1 and -5. Let me show you what happens on the next one, and then we'll start talking about why this is. This is basically an observation that somebody made at some point. If the discriminant is exactly 0, okay, so different quadratic, different values for A, B, C. Okay, so in this one, A is 1, B is -2, and C is 1. And here's the discriminant highlighted in red, and you get exactly 0. So can you do the square root of 0? You betcha you can. The square root of 0 is 0, right? So what happens in our quadratic equation? If the square root is exactly 0, this whole plus or minus thing kind of goes away, right? Plus or minus 0 doesn't do anything. So what ends up happening is you get exactly one real root, right? So no matter what you do, you get 1. Does that make sense? Compare it with what happened before. See if this starts to make sense. So this is exactly 0. As long as the discriminant is positive or greater than 0, you are always going to have some square root that you can compute here, right? Like if this was square root of 1, you would have plus or minus 1. We already looked at the case of when it's exactly 0, it goes away. So as long as this is a positive number, you are going to have a plus or minus in your equation, and you will always get two x-intercepts. Yeah? Let's look at what happens in the last case. So the last thing that could happen is if the discriminant is negative, then you get no real roots. Okay, so this particular one, different quadratic. So A value is 1, B value is -3, C value is 10. Check out the discriminant, you get -31. Well, we can't do the square root of -31, not in the real number system. So it says there's complex roots, but let's just add no real roots. And when I say the word real, I don't mean like, get real, man. We're talking about the real number system, okay? So if it's negative, if b squared minus 4ac is less than 0, that means that when we go to the quadratic formula, we'll get a negative square root, we'll get no real roots. Here's that parabola. It's just opening up above the x-axis, so we'll never cross the x-axis. So those are the three things that can happen, okay? Discriminant greater than 0, how many roots? Look at the notes right in front of you, too. Discriminant exactly 0? 1? Less than 0?
No.
None. Okay, so you have to memorize that part. This formula is on your formula sheet, but you got to memorize like how to interpret your answer. So sometimes you might just get a question saying, oh, well, how many roots does this parabola have? Or whatever. We'll look at all the different kinds of questions that we'll do right now. But that is the theory behind it all. Okay? So you either get 2, 1, or 0. So here we go. It says without solving, determine whether the equation, blah, 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 has 1, 2, or no real roots. So this is a question where you're going to examine the discriminant. I think you do.
These are different questions.
I think you just have to flip the page. Yeah, you might skip a slide. Yeah, occasionally like there's a slide that we skip, but
You slipped like
4 slides?
Yeah.
Oh my word. Holy smokes. These are just the bare necessities we're doing. The bare necessities of the discriminant. Did everybody find it? I'm told you just have to flip.
How many slides?
You guys should go on CNN. You guys are like so exaggerated. You have to flip the page 1 time, 2 times.
It's on the back page.
It's on the back page?
It's like right above the homework.
Okay, all right. Yeah, there might be a chance that the next example we gotta add. I printed these booklets a little while ago. So everybody found it though?
Yeah.
Excellent. I apologize, I'm really sorry. Okay. So, it's like looking for a needle in a haystack or something. So here's the discriminant. Now we know that if it's greater than 0, then what? There's 2 roots. Right, just to summarize, if it's equal to 0, then there are how many roots? 1 root. And if it's less than 0, then there's no roots. So what do we got to do? We got to make sure that this thing's set equal to 0, right? Set equal to 0? Yep. So then we can grab our values for A, B, and C. So A is 5, B is -8, and C is 6. And then we go calculate what is B squared minus 4AC. And then we'll interpret our answer using that background knowledge that we have. So we're going to go -8 squared minus 4 times A times C. So that would be good for like just showing me your initial work. You could potentially jump to an answer. I don't recommend it. But when you go -8 squared, you get 64. Subtract. I would figure out all this. So what do you have? You got 5 times 6, 30, times 4 is 120. That shouldn't be hard, right? 4 times 30. Let's go 4 times 3, 12, add the 0, done. Now what do we get when we subtract it? Like -56 or something? Yeah. I think. All right, so what's our conclusion? Our discriminant is -56. So when we go do our quadratic formula, we'll get the square root of -56, which we can't do. So here we are, no roots. So you would say, since the discriminant is less than 0, we have no real roots. And you're done. So like on our test, like you can get a couple questions on this, like you might get one like this. Don't be tempted to solve, right? Like so some of you might say, oh well I'll just factor it and see what I get.
So are you supposed to use this before using the quadratic formula to find if there are roots?
Not necessarily, it's just a convenient thing you can do.
Alright, so if
Yeah.
we do this, should we like write it down?
Yeah, like you gotta show me your work. You can't just like, I don't know, figure out that it's not factorable and then be like, oh, there's no real roots.
But if it is factorable, do we have to show this or can we just not?
Well, this question says without solving. So what they mean is like, you can't factor this.
Okay.
Yeah, if you show me your work, you factoring it, then I'm like, well, I was basically asking you to use a discriminant.
Okay.
Yeah, so just follow the directions in the question. Yeah, when we start graphing these, the discriminant is just a quick way for you to figure out whether or not you can expect any x-intercepts. Yeah. Great. Okay, let's try another one. Now, I worry that maybe it may or may not be in your book, and we'll find out in a moment. I think there's only like 1 or 2 more questions. So you might have to just add it. I think I updated my notes last year, and I get these printed in June, so We're going to skip that one. It's the same question. So do you have this one? I believe it should. Yes? Good. Okay. Yeah, we skipped the try it yourself. Now over here, is this in your booklet?
Yeah.
Yeah, okay, so I'm just reminding you that when you're solving an inequality, if you multiply or divide by a negative number, you have to flip that inequality sign. So we'll see where that comes in. This is a favorite question where they basically replace one of these terms with a k. And they say, so what values of k would this equation have two real roots? Okay, so the discriminant is what tells us how many roots to expect. And in part B, they're just asking, can you actually tell me a value of k? But for part A, you need to figure out the equation. So let's take a look. What's their formula for the discriminant? You guys have it in your notes. What's the formula for the discriminant? Yeah. Excellent, okay. So I heard that. And then if it has two real roots, well, what is it? Greater than 0, equal to 0, less than 0? Greater than 0. So if I can solve this equation, I might be able to figure out values for k that work. Now this is already set equal to 0, so I can go ahead and just write, well, my a value is 3, my b value is -5, and my c value is k. So now I can just plug that into my equation, so I can say, all right, well, b is -5, so I got -5 squared, minus 4 times a, which is 3, and c, which is k. And that needs to be greater than 0. So I have an inequality with one unknown. Can I solve it? Yes, because I've got one unknown. So, square -5, you get 25. -4 times 3 is -12k. That needs to be greater than 0. So I'm going to move this over to that side. I'm going to isolate my variable. So I have -12k greater than -25. Now the reason I reminded you ahead of time is this was back in grade 9 that you were solving these kinds of equations. And I'm going to have to divide by -12 to solve for k, right? So when you divide an inequality by a negative number...
Grade 11s. If your last name starts with T, please go to the library.
Get grade 11s. You have to flip that inequality sign. So that's going to be less than now, and you can leave that as 25 over 12. So as long as k is less than that number, we will have two real roots. Now in part B, they say, well, okay, what is a possible value of k, and write the equation. So it might be useful to know approximately what is that number as a decimal approximately. How many times does 12 go to 25?
2.
Like 2 point, and that's going to be something, right? You have like 1 left over. So it's going to be 2 point something. Okay, so as long as I'm less than 2, I'm going to be okay. Alright, so you might choose like k equal 1. Right, so if k equals 1, what does my equation look like? Well, my equation would be 3x squared minus 5x, and then it says plus k, so plus 1. Or, can you guys give me another value? Yeah, 0.5. So it's going to be less than this. So would like -7 work? Is it less than this number?
Yeah.
Then it would work, right? We did all this work to find out that as long as k is less than this, which is basically 2 point something, we're going to have, what is it? 2 point?
2.08 or 8. 2.08.
08. Yeah, okay. Perfect. So yeah, maybe you say, okay, k is -7. What's the equation? There. Okay? I don't know why. I remember there was one test one year where we basically had this question on it, and then I just said, can you tell me two values of k that work? And everybody left it blank. But everybody got part A, where it was like, hey, this is, I don't know, this is your magic formula that you need to follow. So, any questions about it?
It's pretty simple. Yeah.
Pretty simple. I mean, obviously you want to try the homeworks, but it makes sense at first glance. Okay, I don't know if I have any other ones. Oh yeah, this is the famous question, the wordy problem. Let's do the wordy problem. Hello.
I had a question about it.
Oh, sure. What's your question on this one before I erase it?
So the K is 2.08. How did we get positive 1 and negative 7? Like,
Okay, so for this one, K has to be less than basically 2.08. If it's less than 2.08, we will have two real roots. So in part B, it says pick a value for K that's going to work. So is 1 less than this? Yeah. So then this should work. And I just popped it into the equation. And then I said, well, let's pick another one. So I just chose -7.
Oh.
Because is -7 less than a positive number? Yeah. Does that make sense for everybody? Yeah, good. Thanks for asking. It's a good question. All right, we're all happy. I'm going to erase it. Okay. And you guys all have the next one? Okay, so that one is the one you have to write. So give me a moment.
Why? Why don't you do that to us?
I made you write two sentences.
Okay.
Two sentences. The square of a number is subtracted from the number. Can the difference be positive? Give you a moment. Oh, I didn't have it. Okay. The square of a number is subtracted. Are we missing something here? The square of a number is subtracted from. Oh, okay. Can the difference be positive? I guess we'll find out. Hopefully, I don't box this one. Okay.
It's always going to be political.
Are we ready? Maybe we can try a couple of practical examples. Everyone got it? Okay, I don't know if this even has anything to do with the discriminant, so let's see. Might just be a word problem because we throw them in at the end. So the square of a number is subtracted from the number. Should we kind of define what our like number is? Like give it a name? Like how are we going to start getting an equation if we don't have a name for our number? So what should we call it? Timothy?
Grade 11, testing starting with U, V, W, please go to the library.
Well, Mohammed suggested Timothy, so I'm going to say let T
Okay.
be the number. Right, T for Timothy. Is that visit my David Copperfield story?
Yeah, Tim.
Tim. Okay. Yeah, and if you want to wait, that's cool, but otherwise you just go on ahead. Yeah. I'm going to put this question on the test then. Just to spite Emma. Just to spite Emma. So hopefully we can do this question because I'm looking at it, I'm like, where's this going to go? Well, let's see. So the square of a number. So what does that mean? I'm going to take T and square it. So the square of a number is subtracted from the number. Oh. So is it this? Or is it this? The square of a number is subtracted from the number. Yes, okay. So I'm just trying to model for you how I think. Like literally I'd be writing this on the test and be like, oh, it's that one. That's the one. Okay. So can this difference ever be positive? So can it ever be greater than 0? We'll say 0. So like let's try some examples.
Yes,
I don't
actually.
know. If T is 3 and I go 3 subtract 3 squared, is that positive? 3 minus 9. Nope, that's going to give you -3. Okay. What if T, I don't know, give me another one.
-3.
-3. Okay, good. Let's try a negative number. So -3 subtract -3 squared. So I get -3 subtract 9. So I just get -12. That's not greater than 0. Good try though, good thought. 1?
Oh.
Well, one will get you exactly 0. Now I don't remember, like I think 0 is considered positive. Like it's really not positive or negative, I guess. So I'm gonna stick with this. I'm gonna stick with that. I think to be positive we gotta be greater than 0. But 1 would be the number that gets us exactly 0. So how are we gonna solve this?
Square root.
Oh, we can do a square root? Okay, I'd be curious to try a square root.
It's true. Let's try a square root of this number.
So what kind of square root should we do?
Square root of
Like 4 or something? Or should it be like a number that, like a non-perfect square, like 6? Let's try that.
Let's try that.
So if we go square root 6, subtract square root 6 squared, we get square root 6 subtract 6. Now I know the square root of 9, for example, is 3, right? So is that going to work?
No.
Like this is going to be less than 3. So 3, basically, something less than 3, you're going to get a negative number for sure. So that doesn't work. Okay, so we can't just do a million examples. What we could do is we could find the discriminant and see what happens. This is a quadratic. So let's see what happens if we find the discriminant. Yes, this is starting to make sense. So this is some sort of quadratic. Now we haven't graphed them yet, but it might look something like this. So assuming it has x-intercepts, the y value represents the value of when we actually put in a t value and do this and get an answer. So anything below this, which is 0, these would all be our negative answers. Anything above it, those would be positive answers, right? So basically we need to ask ourselves, do we have at least one square root? Or do we have at least one root? Okay, so this would give us answers, or a parabola that was maybe centered right here and hit exactly one spot would mean we have exactly one possibility where we get exactly 0, which we weren't sure if that was positive or not. I don't think the number 0 is positive. I think it's kind of neither. But, so let's see if the discriminant is greater than or equal to 0. So what's my value for A, B, and C? So -1 is A, right? Because it's ax squared plus bx plus c. Now we have everything on one side of the equation, so that's good. What's my b term? So that's the x term, the one that just has a power 1. So what's b? 1, and the c term? 0. So let's find the discriminant. Let's go b squared minus 4ac. So we can plug in 1. We can plug in a equals -1 and c is 0. So basically this whole thing disappears because 0 times anything is 0. We just get 1. So 1 is greater than 0. So how many roots do we have?
2.
We have 2 real roots, which means we have this kind of a situation. So there will be numbers that give us a positive value. Okay, so to answer it, will the difference ever be positive? We can say yes. It will be because we have 2 x-intercepts. So we didn't find any of the values, but we just figured out, yeah, there's answers out there somewhere. And if we graph it, we could go find the answers. So let's do a little extension here. If we go to decimal, and hopefully we're right. Of course. So it was x minus x squared. There we go. If we zoom in here, well, that makes sense. So any decimal number should be an answer. Let's pick one.
0.
Hello.
Could you just explain the last step? Like the 1 squared force times -1 times 0?
Back when we were here, right?
Yeah.
B was 1. This was -1, right? Yeah, well, 0 times 1 times 4 is 0.
Yeah.
So you're subtracting 0. So you have 1 subtract 0, you get 1.
Oh.
Yeah. Yeah, all this is gone. All gone. 0. Easy peasy. Alright, let's take a peek here. So we got a graph. You're going to need a calculator for this, but basically any decimal number for t should apparently work. And we're going to get a very small decimal number for y. So if we chose 0.5, so what the formula was, yeah, t minus t squared. So if we did 0.5 subtract 0.5 squared, yes. I do believe if I do that in my head, is it 0.25? Can someone check 0.5 squared?
It's already done.
Yeah? So you get 0.25. Is that greater than 0? Yes. Isn't that interesting? So that's an application of how you use a discriminant to maybe solve a problem. Math has real uses. It really does. Why might that be important? I don't know. This could be like a temperature function for something, and it's like, oh, the element that we're looking to create only happens from here to here, so our temperature needs to be within. I don't know, like there's all sorts of crazy ways that this ends up relating to the real world. It's just so sad to me we never get to see them much in math class. Anyways, I'll stop the video there. Bye bye. That was scary.